Welcome back. This is the Tutor Wizard. I'm Adrian. Please subscribe right here. Hit the notification bell. You'll get notifications for this series and a bunch of other ones on our channel. Linear Algebra 1. Chapter 1 is Systems of Linear Equations. Section 1.3, we're going to do one equation and one unknown recap. Basically, what that means is this lecture, we're going to do a summary of solutions to one equation with n unknowns. Let's do that. All right. This is Noodles. I'm Adrian. Now what we're going to do is systems of one equation in n greater than or equal to two unknowns. If you have one unknown, go watch the previous videos and we'll see how to systematically do that. For now, this is the general form of one equation and one unknown. Okay, you don't want, it doesn't want to see. When we have one equation in n unknowns, this is the general form of how we're going to put this. You can group all of the like terms together. Classically, we put the constant on the right-hand side and all of the variables on the other side. And when we have n of them, we have to index them. What this notation is going to start doing when we have a system of m equations and n unknowns, we're going to have more rows and more equations, and it'll get more complicated. Therefore, what we're going to do is start double indexing the numbers. What the green index tells me that I'm in equation 1 or row 1. In the system right now, we only have one of those, so it didn't change. Now what we do is focus on the red ones, and the second index, or the index on the variable, tells me which variable we have, and it also tells us which column we're in when we start talking about larger systems. And of course, to recap, at first it all looks like some foreign language, but these are fixed real numbers, and the x1 to xn are in fact the unknowns that we seek to find so that we can make the equation true. We're trying to solve this linear system, or this linear equation of one equation in n unknowns. We mean find all ordered n tuples x1 to xn that make this statement true. Let's go over the general solution to this scenario. If we're solving one equation in n unknowns, specifically again, we're assuming for simplicity that all of these are non-zero. Otherwise, I'm not talking about an equation in n unknowns. I'm talking about n minus 1 unknowns. You could reduce to that scenario, and specifically if n equals 1, we're talking about one equation and one unknown, which we systematically took care of. Therefore, we're assuming that all of these are non-zero, or in particular at least one of these guys is non-zero, so we focus usually on the lowest index now. This is the reverse, especially when there's only two of them. This is talking about lines in the plane, and usually we say y is a function of x. Now what we're going to do is reverse that, and therefore x1 will now depend on x2 or all of the higher indexed variables if there's more in the equation. What we do with that now is classically, this is our starting equation. I bring all of them except for x1 to the other side of the equation. We're solving for x1 in terms of the other ones essentially. So you leave that one on one side of the equation, bring everybody else to the other side, and then I want to isolate x1 by itself. Luckily, because a11 is not 0, we know that a11 inverse exists, which we call the reciprocal 1 over. And we divide both sides by a11, and we get x1 depends on, well, that's a 2, the other n minus 1 variables. Those guys are free variables, and unfortunately we're going to use t1 to tn minus 1 with another indexing. Don't worry too much about that. Most of the time, especially when we start, there will only be one or two free variables, and we'll call it S and T or S and T and R, and then it'll get out of hand from there, and you'll be like, what's going on? So I promise I won't give you in the videos anything that has more than 3, possibly 4 free variables. Maybe I've lied. Have I lied? You'll have to watch to see. Let's do the specific general solution and what that looks like in this case, and then we'll do one quick recap example. So for one equation in n unknowns exactly, the general solution is given by this hot mess. We're going to do an example right away, but the idea is you bring all of these to the other side, you divide by a11, and you get x1 in terms of the other n minus 1 free variables. And we denote x1 or xn to be the first variable. Call them whatever you want, s and t and r eventually. Hopefully you don't have to index. And then we have n minus 1 free variables, and x1 depends on those. And what that's going to be eventually geometrically is each free variable that you get will be a one-dimensional object, which is the solution. Any point on that object will be a solution in your n space. So if you have 2 free variables, it's a plane. If you have 1 free variable, it's a line. If you have 3 free variables, it's a copy of 3 space inside some higher dimensional space, and then it'll go crazy from there. So each free variable denotes essentially a dimension in the solution space once we get into the geometric interpretation to that, which will be the next lecture. Let's do a quick example. so you don't have to look at these indices. Example 1, we're going to find the general solution to this equation. One equation in 6 unknowns, it looks like. Now you can see also the idea of, yes, the universe doesn't care when it gives you problems, so when you're solving them, you may have a large number of unknown variables, and using X, Y, Z starts W, and you have to play the game of what should I call the symbols. Instead, you just pick one symbol, X, and index it, and then you say you have 6 things. That's a much better way to do it when you have a whole bunch of things. Now what we're going to do is solve this equation, one equation in 6 unknowns. How do I do that? We focus on the first variable, x1, and we move all of the other ones to the other side of the equation. That immediately gives me 3x1. Now you can see all the a11, a12, they're numbers now. Yay. I picked some horrible numbers, but you should know that's a number, not a letter. E is the number of the day, not the letter of the day. x1 is now equal to 1 minus 5x2 plus 2x3 minus pi x4 minus e squared x5 plus the square root of 7 x6. We've moved everything to the other side, and then now I have, it's much easier to see a11, and in fact all of them are not 0, otherwise they wouldn't be there and I wouldn't be talking about them. This says essentially that because 3 is not 0, I can multiply by 1/3 on both sides, and I get x1 is equal to 1 over 3 minus 1 over, or 5 over 3 x2 plus 2 over 3 x3 minus pi over 3 x4. Is that larger or smaller than 1? Larger, minus e squared over 3 larger than 1 x5 plus root 7 over 3 less than 1 x6. This is our solution, and then what's our general solution going to look like? That's going to say that x1 is equal to 1 over 3 minus, now we have to, this is what you have to do and you always get stuck. You're like, for some reason they're changing them into new free variables. So starting at the back, I just have to make all 5 of these guys free variables. So I'm going to start with x6 is t, and x5 is s, and x4 is r, and x3 is, I ran out, it doesn't matter, p, and x2 is q. There, I didn't even index them, but that, if we were going to index, that would be T1, T2, T3, T4, T5, which is 6 minus 1 in our horrible indexing. But I just picked 5 free variables. Why did you change them to a new name? Don't worry about it right now. We'll explain in the next videos. Watch those, and it will become clear, hopefully. I'm trying to add clarity, not remove it. I'm not sure of the effects, though. What do I do with that now? Put them in there, and we get 5 over 3 x2 was q, plus 2 over 3 x3 was p, minus pi over 3 x4 was r, and minus e squared over 3 x5 was s, and then plus root 7 over 3 x6, which was t. This is the general solution. We can write that out nicely at the top to show you in the fancy form that I showed in the last scene, but this is the general solution. Let's move that up and put it in its final form and the way that I expect to see it when you hand it in, hopefully. So for the general solution in its nice form, the way it should be submitted ideally, we had one equation in 6 unknowns. We move 5 of them to the other side, solve for x1 in terms of x2 to x6. We make x2 to x6 free variables. These ones, if you're trying to study on your own and doing this, color coding, your memory will be happy when you match that this is where they're going and this is where the information is coming from. I set the first 5 equal to free variables. I solve for x1 in terms of those other 5, and then we get 5-dimensional hyperplane in 6 space, which is the solution to all of this one equation in 6 unknowns. We'll get interpretations of that in further videos. Please subscribe right here, hit the notification bell. I'm the Tutor Wizard Adrian. I'll see you next time.